Okay, for the relational design, I still would like to provide you with the motivations why we need to study this section. According to the previous section, we have designed the ER diagrams and we further translated them into relations, or sometimes we may have a set of relations like R1 to Rn, right? And the next step we need to do should be specifying all the constraints we have on the relations, right? And then we can further implement the relations in SQL by creating some tables and also design some queries on it, right? And then we can start to use it and make sure the constraints are always valid in the relations. It should be everything is good right now. However, we may find some problems because the relations we can get from translation from the ER diagram cannot be perfect. They may not be well designed and can also create lots of problems for us. What does this mean? We'll provide you with an example, right? According to the previous section, we can create the ER diagrams for a person, right, with SSN, address, as well as phone number. And we can further translate the ER diagram into a relation with the SSN, address, and phone number as attributes, which are shown here, right? And when we store the data into such a relation in our database systems, we may find some problems. The first column is SSN, the second column is address, the third column is phone number. According to our understanding for the person, right, the SSN should be the key for the person. However, when we store data into tables, we may find lots of problems. For the same person, the same SSN, we may have multiple different records, right? This is the first person, address is 10 green, the phone number is 201 555 1234. And for the same person again, on the same address, he also have another phone number. It's true, right? The same person can have multiple phone numbers. And then we have another person, the person also has two numbers on the same address. It is beyond our expectations. Before we assume the SSN can be the key for the person. However, in the real world, it is not the case, right? For the same person, SSN probably is not enough for storing the information for the person. Also, for the same person, we store his or her address multiple times. Like for the first person, we have two addresses for the person, right? 10 green, 10 green. They're redundant, right? And for the second person, it is the same. We have two addresses for the same person. We have redundancy for the address storage. According to our previous understanding, redundancy is not good, right? First of all, it may waste lots of storage space, and it can also create lots of problems when we do the updating or deletions. For example, if we plan to update the address for the person with SSN 123.321.99, if we only update one address here and forget to update the remaining, we may have some inconsistent address for the same person, right? It will be very similar for deletion. If we delete one record for the person in a table, now the first row, and we forget to delete the second row, then we may have some inconsistency as well, because we may have this person still in the table, even after we delete the person on address by phone number. Right? And for the same table, we may also find another problem. It seems for the table, the SSN can no longer be the key, right? And it seems the phone number can be the key instead. Is it true? From the perspective of physical meanings, for the person, right, SSN should be the unique ID for the person. However, for this table, it is different from our expectations. The phone number is more like a key for the person. Then it is a problem we have right now for this relation, right? And the relation we can get from translation can be not perfect and have some problems when we use them for data storage. Because of this problem, we may need to derive some better relations instead by using this relational design, this section instead. And how do we do the polish and redesign? Normally, based on the role relations we can get from the translation in the previous sections, we start with original relations, and we keep transforming them until we can get some good design of the relations. We will introduce the transform these rules and algorithms later, and we first need to introduce what is a good design of the relations. What are the desired properties for these new relations which are good? So we have some design properties for the good relations. First of all, these new relations should preserve all the information in the original relation, right? The original relation is not perfect, but it can carry lots of information. After we do the transformation, we need to make sure these new relations can still preserve the information we had before. We also need to make sure that these new relations can have the minimal amount of redundancy. Redundancy is very bad for database system design. We should avoid the redundancy as much as possible. And this R*, these new relations should have the minimum amount of redundancy. This is very important. Also, the relation R*, the new relations, must be dependency preserving. If the original relation is associated with a set of constraints, then it should be also very easy to check if this constraint also hold of the new relation or not. We need to make sure we can preserve the original constraints that we have in the new relation as well. And beyond these three properties, we may also ensure this new relation should give a very good query performance. This is the only option because it may have some contradictions with the previous three properties. We only have a trade-off between the performance versus redundancy reduction. So we will introduce this later. Therefore, you know the target for this section. Given the original relation we get from translation, we plan to transform them until we can get very good relations. We have some properties, desired properties for these good relations, and we're going to achieve them via the transformations. Okay, so then the question will be, how do we recognize a relation is a good relation? Right? We have desired properties we introduced before. Then how can we quantify a relation is good and can meet our requirements and the desired properties? This is one question, right? Another question is, how can we do the transformation from this R into the R*? So to resolve these two questions, what we need to do or to study in this section is a scenario of normal forms. This normal form is also called as NF for short. We have different normal forms to be introduced in this section, which can both recognize a good design of R* and can also help us to do the transformation from R into R*. Okay, so this is this section. We will talk about these normal forms. And database experts have developed so many different normal forms to help us. And among them, the most important ones are the BC normal form. BC, I mean the boys called normal form, the third normal form, and the fourth normal forms. We will talk about these normal forms in details later. You just need to remember we have three normal forms to be covered in this section. Beyond these three, we have many other normal forms as well. We will mention some of them later. Okay, so this normal form can be very helpful. If a relation is in one of these normal forms, then we can guarantee this relation can achieve certain properties. In other words, these normal forms can help us quantify if a relation is good or not and can meet certain properties or not. For example, if the relation R* is in the BC normal form, then it is guaranteed to not have any certain types of redundancy. We may still have some redundancies, but we can eliminate some certain types of redundancy if we can ensure that this relation is in the BC normal form. And database experts have also developed so many algorithms to help us transform a relation into a star, which is in some of its normal forms. We will show the transformation algorithm as well in this section to help us transform the relations. Okay, so this is a motivation to study this section.